What's up, folks? Welcome back to the channel. In this video, I want to talk about a recent presentation that I did at the Open Data Science Conference in London. I got to talk to some pretty cool folks about augmenting research workflows with large language models, and I thought that it could be cool to have this as a video as well. So I'm going to do the same presentation, and I hope you like it. All right, so this is some stuff for the conference, but if you want to check out the repo, I'll leave a link in the description. And now let's talk about what we're going to discuss. So first, I want to talk about this idea of LLM tangibles. Then I want to talk about cool LLM-based UI patterns. Then I want to talk about level 0, which is prompting for better research workflows. Then level 1, which is about Pydantic and data structures for research primitives. Then some cool extra stuff, because this is a video so I can do whatever I want. And then I'm going to probably discuss with a little bit of code some other interesting patterns of working with AI to do research. Okay. So what is this going to be about? So we're going to talk about using large language models to help you research as an academic researcher, but also as a informal, someone who just likes to research stuff. And the first idea I want to talk about is where the concept of augmentation came from. So it came from this very cool essay by Douglas Engelbart talking about augmenting human intellect, a conceptual framework. And in it has a few cool points that I want to point out. He talks about augmenting the human intellect as a way to think about increasing the capability of someone to approach a complex problem or situation, to gain comprehension to suit a certain particular need, and to derive solutions to problems. So it's about gaining a degree of comprehension in a situation that previously was too complex. And it's not about clever tricks in certain situations. So it's about a whole integrated domain where hunches, cut and dry intangibles, and the human feel for a situation coexist with powerful concepts, streamlined terminology, and notation, sophisticated methods, and high-powered electronic aids, etc., etc. So I want to talk about, okay, so what are Douglas Engelbart was the man. And I want to talk about what are the LLM tangibles, what stuff we can actually do using large language models that can somehow augment and enhance our capabilities to research stuff online, to, do knowledge work. The first I want to point out is some cool LLM-based UI patterns that I found recently that I think are really, really cool. The first one, if you don't know what Elicit is a research assistant tool. Let me just quickly show an example. So if you go to elicit.com, they're not sponsoring this video, by the way. I just really like the tool. You get this very cool UI where you can ask a research question. And then what you get is this very interesting interface. So I'm going to just use an example that I've done before. So let's say, does watching videos of people performing a motor action help with learning that motor action? Something like that. It's not very well phrased, but now I'm going to run it. And what I really like about Elicit is that it was one of the first UIs that I saw that used large language models in a new, interesting, special way. So you get a stable-like structure where you get the papers here on the left, and then on the middle, you get a summary. But the cool thing about this is that you can use large language models in the backend to integrate more information in the stable. However, you choose to do that if you want to do that. For example, I have here on my right, add column, summary, main findings, methodology, intervention, outcome measure, etc. Right? And I can come here and I can click main findings. And now what they're doing is they're using large language models on the back end to extract the main findings from these papers and put that, but not only for one or two papers, but for a bunch of selected papers. So you're working across multiple papers at once in one interface. And for me, this is one of the first times that I saw a pattern of usage of LLMs that was usually about, that was like actually clearly about amplifying what that research could do, what that researcher could do. And I thought that this was just absolutely mind-boggling. I thought it was really cool. And then going back to the presentation. So yeah, This little during the presentation, I didn't do the actual demo on the browser because these things can go really badly. So I just showed it on the right, and I explained what I like about this is the fact that you have these primitives around large language models. Like instead of having like you prompt a model to do each of these things, no, summary, methodology, intervention, etc. Right? Awesome stuff. Really like it. The second pattern of usage that I've seen with UI patterns, with UIs that I really liked was from a presentation by Amelia Wattenberger called Climbing the Ladder of Abstraction. You can find this presentation on YouTube. And I'm actually going to hop over to that video. I don't know if that's a copy strike law. I'm probably not going to do that. But what she talks about in the presentation that I really liked was that you could zoom in and out of a book using large language models, right? If they can summarize information at different levels of abstraction or difficulty, you can, for example, have all the chapters of the book in one page of the PDF. So you can zoom in and out of how much you want to read of that particular book. So if you want to get a sense for where the book is going, you would use the semantic zooming feature to essentially zoom out and see all the chapters and what's going on. So I think I saved an example here. Yeah, this is a single bullet point summary for all the main sections of the chapter, and you can do that across chapters as well. And I think semantic zooming was another concept that I really liked. The third and last one to mention is by a tool that was recently released. It's not really a tool, it's more like a demo associated with a paper where they talk about using large language models to do this latent space style exploration of ideas. The tool is called Luminate. Go check it out. I'll leave a link in the description. And what I found really interesting about this tool, which I'm actually going to demonstrate. So let's go to the demo. So what's really cool about this tool is essentially it's supposed to be a tool to facilitate ideation. So I'm going to put here, and what you get is this UI that you can ask AI for ideas, right? And then you can explore these ideas across dimensions organized by a large language model. So I can say a story about let's say a funny short story about a man who quit his job to become I don't know, clown. All right. So what is interesting about Luminate that I found quite fascinating is this idea of exploring dimensions of a particular concept, idea, whatever. So imagine you get the output of the model here, right? You get the story, you get this very nice story, very, very cool, very interesting. But when I zoom in into these nodes here, you get these options of ways of looking at your idea, which is so cool. Like it's here I'm exploring this idea from the perspective of tone, right? But you can explore different things. So I can click on retire clown's defeat, and then dreams and defeat, and then failed clown dream, and I am exploring different tones for this particular story. But I can come here and I can say, okay, I want the humorous tone. And now from the options of stories generated by the AI, I can see which ones are more humorous or which ones are more satirical. Or I can come here and I can say, okay, cool, that's style. And style I want is something a little bit more dark comedy sarcasm. Let's see. So I got 3 options and we can go and see what that option is about. So and I can also select the dimension. So here I was selecting by tone, setting, style, etc. But you can go for character development, right? And now you can essentially in this character development dimension explore where the stories fall across this particular dimension, and then you can compare. I can select another one like character developer versus humor. And then I can see super funny, but with no character development. And then there are options that are like, okay, kind of funny, but minimal character development, etc., etc. And then when I go, let's say that I really like the retired clowns defeat option, right? Let me just, I can zoom in to this option and I can see more about this idea. So I can zoom in, I see this version, right? Because this tool is also implementing semantic zooming. And if I zoom in a little bit more, I see more about the story. So here you have a summary of the story, structure, because in this way, what they're doing here is they're using large language model capabilities to allow you for optimized exploration of ideas. So they're thinking about how to organize the space so that you can get to what you need faster and explore more effectively. So not necessarily how the model does it for you, because that wouldn't make any sense and that wouldn't be really fun. So I can come in and now I zoom in and now I see the whole story. So I really like this pattern, and in combination with the other ones that we've discussed. So this one is semantic zooming and Elicit with the table-like structure. These are patterns that really inspired me to talk about how we could think about other ways of using large language models to augment our capabilities. And if you want to check out their paper, it's really interesting. They talk about how they got to essentially build this. From what I understood from the paper, you have a somewhat, it's not a simple pipeline, but essentially you get this prompting for design space. So you first start with some prompting steps. The first one being feed the input from the text editor into the LLM API call to generate these dimensions. And then Luminate transforms the generated object to form a list of requirements per response by selecting a value from each dimension. And then the second LLM step feeds each list into separate API calls and generate all the responses in parallel. And then the generated responses are then visualized in this response space. Essentially, it's not, you make a couple of in parallel calls to this LLM, and then you get this space you can explore across dimensions that make sense, etc. It's I think this is a pretty cool idea. Now, all of that was built on top of simple prompting based atomic usage of artificial intelligence. And what I think it's interesting is that you have these granular functionalities that help you reduce cognitive load. So what are the tangibles in research? When we research information, what are the tangibles that we could find that help us kind of get more stuff done? When we think about research information, we usually think about this very simple loop of maybe you have to collect some data, right? And then once you've collected the data, maybe you analyze it, you understand it, and then you generate some hypothesis about, okay, maybe this is true, maybe that is true. And then you figure out an experiment that can test your hypothesis, and then you implement that experiment, and then you observe, right? You accumulate more data, you observe, you think about stuff, and then you go again in this loop. And in terms of how we can find within this simple loop of research a bunch of ways to use large language models effectively, there's a really cool paper called Machine-Assisted Mixed Methods, Augmenting Humanities and Social Science with Artificial Intelligence. And essentially what this paper discusses is just this index of different ways that machines and humans can coexist in research and be more effective together. And it's a really cool paper. I advise you check it out. I didn't read it completely, but I did get some of the stuff. I did check some of the stuff because it was interesting for what I was doing. Okay, so going back. Now, where was I? So, some ideas that I had initially were, okay, so formulating research questions, gathering evidence, data collection, hypothesis testing, hypothesis generation, evaluating sources and analyzing data, conclusions and implications, doing literature review, constructing arguments, validating arguments, and writing and rewriting the actual text for a paper, etc. Right? So these are some ideas of ways that, like, opportunities to find effective collaborations between what large language models can do and what people can do. So what I call level 0 for prompting for research is essentially just good prompts, right? This is something that probably a lot of you will have seen before. And some cool, simple concepts and ideas, just to understand what I mean here, is that we're going to use system messages as utility functions. Essentially, this was inspired by a really cool repository that I would love if you checked out, which is called Fabric, by a fascinating guy that I really want to meet called Daniel Missler. And essentially, it's a awesome repo. And Fabric essentially is what they're trying to do is let's use large language models at this granular level and build these components, like finding new sources of great ideas, extracting key points, etc., etc. And it was in this repo that I saw for the first time this idea of now use system messages as utility functions, as essentially the system message transforms the large language model into this component pattern, etc. And if we go over here and we check out one example, like analyze paper, we go to system.md, and this is the whole system message with a certain structure. You have identity, purpose, steps, output, etc. So fascinating, like it, love it, check it out. So system messages as utility functions, manage prompts as tools to perform granular actions. And these actions performed by the model should be reliable, easily verifiable, produce at least one meaningful transformation of the data, and that's it, okay? So system messages as utility functions and managing prompts as tools to perform granular actions that are reliable, easily verifiable, and produce at least one meaningful transformation of the data. So if I go over to I'm going to go over to my notebooks here, and we're going to go to the first notebook. And I have a few examples of prompts here that we can play around with. So here I have the API call to the ChatGPT setup. All right, so I'm just setting up the client. The model is going to be GPT-4o-mini, but you could use GPT-4o. I set up a function to call the ChatGPT model. And then I can set up my kernel here and reload. There we go. Kernel, and then augment. There you go. And now I can come over here and say, okay, first example of a system message is for constructing an argument. So I say something like, you're a research expert specializing in constructing arguments. Your task is to build logical and persuasive arguments based on a given topic, and then identify the claim, list the key supporting points, organize the points. Essentially, all these system messages for this type of stuff are going to be somewhat well-defined, where you define first the behavior you expect, and then how you want the data to be processed. Usually I like to have a few set of steps, etc. And also some message on how we would like the model to respond. And remember this part, because the next phase of this is going to be using structured outputs, where we take this to the next level. Then I send a prompt with a simple claim that I was just generating with AI, just so that we could get an example. And then I construct my argument following the structure that we were talking about before. So I have the key supporting points, and then I have the logical flow, everything that I asked somewhat, right? List key supporting points, list the flow, anticipate counter arguments, provide concluding statement. So rebut is right here, etc. So it's pretty cool. Another one would be to do something like evidence validation, meaning you're a research expert and you're specialized in assessing validity and utility of an evidence. The purpose is to assess credibility and relevance of provided evidence. For each piece of evidence, you will do these things: evaluate credibility, assess evidence relevance to the claim, check for potential biases, verify currency, provide validity score. Now, folks, it's important to note that I created these as a way to demonstrate this whole concept and idea, but this will be something that people would customize, right? And this would be something that would be particular to how certain people do certain types of research. And this probably would change quite a bit when you change from a field to another. But I think it's interesting to think about when we think about the primitives of the process of researching truth and doing science, what are interesting ways to describe each cognitive procedure, I guess. And I think this is interesting. So then I did I generated an example with some evidence and then evaluating whether or not that was credible. And then the source credibility, relevance, bias, currency, validity score. I mean, I don't know if I agree with everything here, but it's that's one example. And then another one that's really interesting. This one was actually inspired by a paper that demonstrated that large language models could be very good zero-shot hypothesis proposers, where essentially use the model to generate hypotheses based on a topic that you're researching. So you essentially say, generate relevant, valid, robust hypotheses. First, you're going to analyze the question, generate plausible options, rank them, suggest experiments, identifying confounding variables, and then provide a list of generated hypotheses. And then, that's what you get when you get an example of a research topic. So I said, how does remote work affect employee productivity? So this is more like research on, work productivity in industry environment. I don't know. And these are the examples that I got. And I have a bunch of other examples here that you can check out on the repo. All right. So this is the first level, using prompts to do better research workflows. Now, I already shared my examples, and I had a Slack channel. Don't have that Slack channel anymore. That was just for the conference. Now, the level 1, and I go 0-1 because I program in Python. So is about research primitives with Pydantic for efficient LLM-based research. So what does that mean? Imagine if researchers could have like coding control, like programming control over what I call semantic data structures, but I'm not 100% sure this is the best way to put it, to phrase it. And essentially what this means is you use structured outputs plus Pydantic, which is a data validation library in Python, if you don't know. And if you don't know, you should know. And essentially create these very cool data structures to represent these primitives, right? So you define them, and then you capture what I call meta components of the research process. Just like we were capturing them through system messages with the large language model before, this is the next level where we capture them as data structures. And then what I propose is that each should have an atomic definition. They should be made for composability, so they should connect to each other easily. And composing them should yield powerful functionality. So then let's check out some examples. So if I go to notebook number 2, it should be number 3. This one, number 2 was actually another thing. And all right, so this one is for a very simple keyword search and literature review type of example, right? Where we're searching for papers and you want to filter out some papers. You want to filter out options. So I have a couple of system messages here. They're going to be a bit smaller now because now we're going to focus our attention more on the data structure aspect of it. So essentially, I have one for keyword search, one for generating search queries for a problem, and one for evaluating the relevance of an output given the research goal. So you're a search engine that translates topics into a list of keywords, you generate search queries, and then this one evaluates, given a search result and a research topic of interest, whether or not it's relevant, and it's essentially just going to return a binary score. It's relevant, it's not relevant, and we'll see what that means. So now we define with Pydantic, which is what I'm doing here, the data structures for that. All right, so the first one is for keywords, the second one is for search queries, and then I have a little function that calls the OpenAI API using the GPT-4o model, and I give the response format, which is essentially creating a structured output response from ChatGPT, and I'm going to return keywords, and this one is going to return search queries, etc., etc. And this is for more in practice research tasks, right? This is like to help automate aspects of research. However, the next notebook that we're going to see, it's going to show stuff that's a bit more cognitive, meta, and you'll see what I'm talking about. So this one is a class called relevant paper, where essentially I'm going to give a relevance score to a research result that's retrieved and a single sentence justifying why that result is good, which is what I'm doing here. So then I have a function to filter the search results by relevancy. And then I'm gonna filter them out, and I'm gonna filter out the search results using that search relevancy. So I loop over all the search results, and then I see if they're relevant. If they are, I append it to a list. If not, I continue, etc., etc. Right? And I didn't implement the save search results because I didn't have to. So then what I do to do an example is just I generate some keywords, and then I generate some search queries, and then I use the archive API to search archive for papers about specific topic. In this search, I'm going to get like 30 papers based on keywords. So I do the search, and this one is for specifically just keyword search. And I get some cool results, and then I get 30 results, and then I filter them out. And from the 30 results I had initially, I get to 23. And I do the same thing with search queries. So I generate a bunch of search queries. And then from those search queries, what I do is I generate keywords based on the search queries, and then I get structured results. And then I do that relevance evaluation analysis. Now, folks, this is not necessarily the best way. For example, a lot of people are now just generating, searching based on the query using large language models, etc. However, for purposes of being thorough and for doing literature review and to make sure that the large language model doesn't leave out anything, I like this more granular approach where the model is just amplifying your ability to find as many papers as you can. And then when you have all of that stack, let's say of thousands of papers, then you filter them out. And essentially, if we could find a way to use this with a local model, it wouldn't matter that you have 1,000 papers because you have a model that can just go through them without you having to do anything and filter out the papers that you care about. So I think this is a cool, interesting example. But now for the more interesting ones, for the semantic data structure stuff, in this example, we're going to get a little bit more meta. So these are the imports, which essentially we're going to be using OpenAI, PyPDF to read up some PDFs, and Pydantic. And what we do is we create data structures for concepts. For example, fact, right? What is a fact? Is just a string and accompanies some string quote, something that validates or justifies or it serves as source for being able to state this particular thing. Okay, this particular example, I don't know if I think I might have made some modification, but no, maybe for this one, no. This I took from an actual presentation by the founder of Pydantic, which is that presentation is amazing. I love using Pydantic. So this example here I took from his presentation because it was part of the inspiration for this whole idea of applying these things to research, right? Because fact is probably one of the most unique, granular and unique components of doing research, right? You want to be able to state as a fact that X and Y are true. And from fact, you can create, for example, Q&A. This is another example that I think I took from his lecture. That I thought was pretty cool because you apply some very simple validation for the answers. For example, the answers should always come with a substring quote that validates the statements that are made in the answer. And then what I do with that is I load up a PDF as text, and then I create a class called a fact extractor that lists up all the facts given a specific page or specific section of a PDF. And then I extract them based on some prompt that's going to contain part of that paper, right? I don't do that for the whole paper because large language models have this issue where when you give it a lot of context, it might be more precise in answering a question, for example. But if you want to do a lot of stuff into that with that context, you might get some suboptimal results. So I like being a little bit more processing less context at once. So I set up a function to extract those facts, and then I load up the PDF, which is what I'm doing here. I load up the pages, and then I extract all the facts from that paper, and I just print them out. Now, it's important to remember, I don't know why I did this particular example, and I will, if I can, show an app that I built to try to play around with this. But my idea was, okay, I want to be able to extract these little bits of a paper, right? These little statement-ish points, and then see what can I do with them. So that was the first thing. And then for example, one of the things that I was thinking is maybe you can make an assessment of the relevancy of each statement that's made on a paper regarding perhaps a question that you have, or perhaps something you want to understand from that paper that's not very clear. And you want the model to use only things that are said in the paper. You don't want the model to be going too much out of, the scope of that paper. And I don't know if this is this is an optimal approach. This is more experimental, folks. And I was just playing around with this to see what kind of stuff I would get. So I guess it's the message to assess relevancy of the fact. It's again, relevancy score and justification. I have a function here that says, is it relevant? I should have used the previous one, but for this example, I didn't need to. And then I say, look, I want to understand how attention mechanism works. And then I assess everything that's said in the paper, fact by fact, which I know is insane because there's so many things there that I can just clean out and remove. But I don't know. I was just playing around with this. This is not like a approach that I think it's for anything more than just experimenting with stuff. And then I get all the relevant facts organized. And then I put them all under one like big string. And then I asked the model to explain to me something about, I think this example was about, yeah, I want to understand attention mechanism. So I say, explain to me how the attention, self-attention mechanisms work. And I got a really good result that when I compared with just giving the paper to the model and not anything else, nothing else, it wasn't as good as this, to be completely honest. So I really like this approach. I got really good explanation of attention, self-attention with all the bits and parts, etc. So you can also use it to create Q&A out of a paper, which is kind of like something that's been more or less becoming more trendy and hyped up right now. A lot of people are doing that because it's super useful. I do that all the time. I think it's really cool. And yeah, I got some pretty good questions and the answers are all verifiable and validated on the paper. And I got to this really granular level. So I don't know exactly how to expand this. One of the things that I want to do is see if I can organize like an infrastructure for research where you have all these primitives you can play around with and then organize the output across processing multiple papers in one table, like you see in an Elicit, and see how we can expand that. How that helps you get to what you need faster. Because what it's not 100% clear to me right now is that this approach will necessarily make you more efficient. It could be that this is just like unnecessary to get to this data structure level and these models working at this. You can always just, ask ChatGPT for something and just maybe give it some sort of context or give it a full paper, etc. But I think there's something here about LLM primitives and so on. So I think it's interesting, despite it could be completely useless. One way to use it that I think it's absolutely amazing and it seems to be quite obvious that's super useful is for generating hypotheses and for inspecting evidence in a paper. These are two options that I really like. So essentially what you get here is I created a class called hypothesis. You have a claim and you have the priors of the hypothesis. So essentially, what is the claim of the hypothesis? And then a list of backed priors that validate this hypothesis, right? That make it a valid hypothesis. So based on that, I write a system message saying, users will ask a question regarding or not the paper presents evidence for or against something, and your output is going to be an argument and evidence for that argument. So essentially, if I think something is true, I'll say X is true. And what the model is going to do is say, yes, X is true according to this paper because of blah, 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 blah. And then it's going to give me also evidence with direct quotes from the paper to validate what I'm saying, right? And when I do that, I set up a function to load up a PDF to test this out. And then I write a very cool class called evidence, right? And now this evidence is going to contain position, right? Position descriptions, and then evidence, which is essentially the next level of this system message, right? It's going to essentially be the second best thing after. So what are we going to do for? We're going to use it as, we're going to have if a paper presents arguments for and against the position, which is something that can happen as well. For example, imagine that a paper has, some evidence that this part of the brain works like this, but they saw that also there's this aspect that, neglects this a little bit. So what I do is I create a class called evidence that gives me a list of positions. And these positions are going to be a ternary score. You can have yes, no, or neutral. And what essentially you're getting is, does this paper presents a specific position? Is it against, for this claim, or is neutral? And then you're going to have a description of that position. So you're going to have 1 to 3 statements presenting the position for, against, neutral, just like the argument before. So essentially, if it's yes, oh, it's yes because paradi parada, paradi parada. And then you're also going to have, for each of these, direct quotes that validate these positions. So to make it super clear, let's do an example, right? So I write a system message to encompass this data structure, which essentially says the same thing. You have the positions, descriptions, evidence, and then I put it into a function. And now I'm gonna, let me see. Okay, there you go. My hypothesis is working memory training in humans might lead to long-term far transfer improvements in some cognitive abilities, right? This is one hypothesis. It's actually a discussion that exists for a while now, since ever, whether or not you can train your working memory in some particular task, and then have that generalized to other things. So essentially improve your working memory. And working memory is essentially one of the most well-described not metrics, but aspects of intelligence that are like almost correlated with fluid intelligence and, you know, being smart. So people that have big working memories are usually pretty smart. So can you train it? So I put in a prompt. Does this abstract, and this is an abstract from a paper regarding this discussion, presents evidence for these statements. So I send that to the function, and what I get is no, it doesn't. And I also get a position with neutral. So let's see and evaluate what happened. So when I read it out, I see, no, this paper does not support the idea as feedback benefits did not persist over time. So because in that particular paper, they saw that the feedback result did not persist. And then the evidence is direct quotes from the paper. So practicing with feedback improved working memory performance relative to a no feedback group for some practice sessions. However, the feedback benefits did not persist across all training sessions and did not transfer to a final test session without the feedback. That was pretty much the idea, right? And now what I'm going to do is I put this under like this little workflow, right? Inspect evidence for hypothesis, and then I display everything pretty. And now I have another hypothesis. Working memory training might lead to long-lasting improvements in fluid intelligence. I got a little bit more, a little bit less strict, because I wanted to see if the model could detect that the paper actually presented evidence towards that. And then this is an abstract extracted. And if you want to check out the abstract, this is the paper that I'm talking about. Effects of working memory training on cognitive and academic abilities in typically developing school-age children. And I inspect the evidence for that. And what you get is yes, which is really cool. So yes, this paper supports the idea that working memory training leads to long-lasting improvements to fluid intelligence. And then why? Results show that training significantly improved performance in verbal and WM fluid intelligence, et cetera, right? So this is so cool, folks, because essentially we went from, we had some hypothesis we wanted to test, and you see that you can put some reasoning in the large language model enough so that it can inspect the evidence for you. Imagine this across thousands and thousands of papers, right? So this is one example that I really think makes this approach super useful. And I would love to see that across thousands of papers to do some actual real research. All right, so that was it. That was the example I wanted to share with you folks. And now for some cool extra stuff, folks, you have the next level of that would be use agents, right? Which is something that a lot of people are using right now. And I think that it should be used with a lot of careful considerations, especially if you're doing things like academic research. But there's some cool stuff that you can do that it's worth mentioning. So essentially, one of my favorite things is iterative research reports. Essentially, you start with something you want to research, but you don't want to go online and go read a bunch of articles and then write up a report. You want a model to do that for you and then just explain what happened. And you want to be able to verify everything that's said to make sure that everything is true, right? So you want to avoid things like hallucination. And what I think it's important is that the rewriting process of the research report should be made easy, because you're not going to write it all, but you want to be able to say, look, in this part, I want you to do this part, I want you to do that. And composability of the LLM generations with LLM CLI is another demo that I want to show you folks. So let's go one by one. The first one, let's see if I can run up GPT Researcher here. So I'm going to use GPT Researcher. So folks, if you don't know what GPT Researcher is essentially a really cool tool that allows you to do research reports, high quality research reports with large language models. I'm having an issue because, okay, so 1 second, folks. So I'm gonna have to install it again. So 1 sec, let's say GPT Researcher. I'm gonna GPT Researcher. So we're just gonna come over here, and the installation process is super easy. There you go, git clone, cd, perfect. That's what I'm gonna do. Okay, there you go. We export some API keys to do this research stuff, etc. I can just install as a bit package, never mind. And okay, beautiful. There you go. So now let's check it out. Actually, no, I actually wanted the other way. So I'm going to install the requirements, and now I'm going to run the app. There you go. Now let's run the app. So when you run GPT Researcher for the first time, you're going to see something like this. It's a free tool, folks. The only thing you're going to pay is the APIs, right? The OpenAI API or whatever other APIs you might use with it. I click and get started. I say, what would you like me to research next? And I can say, write a report about effective and generalizable procedures for training working memory. And then I want it to be fast, because I just want to show everyone. And then you have different styles that you can generate with the report. I'm going to say objective. Okay. No, let's just say objective. Yeah. And then I don't want it to, I wanted to use the web, but I could use just my documents to do that, which is also as well, which is really cool. I click in research, and now the agent goes out and researches the information for us. So it's researching, it's reading up, it's doing stuff, it's collecting resources, right? It's doing a bunch of awesome stuff. And now it's going to be writing summary for the research task. So it was super cheap to perform. As you can see here, folks, you can see the cost. So for me, it was like less than like a cent, I think. And now it's generating a very cool, interesting report. So challenges and controversies. This is so cool, right? This is something I never get tired of using tools like that, because it's just so cool. Look at this. It's the quality of the report is the thing. Each section, each paragraph comes validated, and it's verifiable directly in the source. So this is a pattern that I really like, working iteratively in these research reports, right? Now, the second thing that I would comment, folks, is that we can, let me see, I can take this, I'm going to download this as a markdown. So I just, let's copy this. So I'm going to go Control A, Control C. I'm going to go over to this part. I'm going to save it as report cognitive.md. I'm going to make sure that it's there. Beautiful. And now I'm going to use a tool, folks, to quickly inspect what was written by the model and rewrite the sections that I think could be improved, right? So I could say Python desktop automate, navigate file, and then I'm going to give this research report. So I'm going to give this report. And now what I give, folks, and I'm going to make it a little bit smaller so that you can see, is, and I just think that this is a cool UI pattern that I think we could also think about. So I navigate these sections, right? And I made this very simple terminal app that allows me to navigate these sections very easily. And I can go, okay, section 1 is introduction, section 3, theoretical background, etc. And if I want to rewrite any of these, I could just, for example, in conclusion, I could come over here and I could say, okay, cool. Let's do something with this conclusion. Let's make it a little bit, shorter or something. I could click enter. Let's return. Yeah, I click enter, and then I say generate with AI, make the conclusion shorter, stating the main finding of the report. All right. So I click enter, and now I generated this with a large language model, and I can compare what was generated, what was before, and what was generated. And with that comparison, let's say I like it. I click on R to replace. And now what's cool is that I can open up the report. Hopefully I can open up the report. And if I can't, I can say cog report. There you go. I'm going to go on preview. And now the conclusion was rewritten to the single statement like I asked. And this app is not perfect right now. It's still adding like the name of the section again and again, which is annoying, but it's fine. The point is that I think this is a new way of working with these models where instead of you getting concerned of generating everything, writing everything, etc., you just want to make sure that everything that's being created is verifiable and it's according to how you want that to be written. And you can work in chunks rather than actual just text, which I think is really cool. All right, so that was it. That was this example, folks. And then the other example that I'm quickly going to show is from the LLM CLI, which is, if you don't know about it, you should know about it. I definitely recommend you check out Simon, I think Simon Willison. I never know how to say this guy's name. I don't know why, but he is, I think, probably one of my favorite people to like just follow in terms of like tools he builds. He has so many cool tools like Dataset for creating SQL databases, LLM now, which essentially is a tool to use large language models in the terminal. Essentially what you get with this is, for example, I have here a report, right? And let's say I wanted to know a single paragraph summarizing this report. I can just come over here and I can cat the value of the report, and then I can pipe that to an LLM. And then I can say, I'm going to use a template. Let's not use a template. Let's say, summarize this report in one short paragraph. So essentially, I'm calling the GPT-4o-mini model and feeding it the report and getting the result. So using large language models directly in the terminal. So I'm going to leave a link in the description for a very cool presentation by Simon about this tool, and you should definitely check it out. I use it all the time. It's amazing. And yeah, I get the correct response. It's amazing. So to conclude, folks, what we want ultimately is useful and reliable transformations of data, information, etc., that can help us get progressively through, that can progressively help us reduce intrinsic cognitive load, right? Can make us be able to think about more stuff by having models simplify things in a way where we don't actually lose our agency in the process of understanding stuff. So one of the things that I've been thinking is how can we make incoherence evident without the disguise of hallucination? And how can we integrate simple evaluation procedures at this individual usage level, right? Because we're not going to do RAG with, complex evaluation, but how can we make it simple so that it's usable by, curious non-developers, non-engineers, non-AI researchers that want to use these models effectively? And what are the best principles, paradigms for effective real-time collaboration with these models? And that's it, folks. Thanks for watching. Don't forget to like and subscribe, and see you next time. Cheers.